All right, I'm going to talk about equivalent fractions. Equivalent fractions is two fractions that represent the same number but have different numerators and denominators. Okay. For example, if we have the number 5 over 15, okay, 5 over 15 is obviously a fraction. It is a proper fraction, okay. It's a proper fraction because the numerator, the top number, is smaller than the denominator, the bottom number, okay. Now, I can reduce this fraction. When we reduce a fraction, what we do is we create an equivalent fraction. Okay? Now, 5/15 can be reduced by 5, but what I reduce the top by, I have to reduce the bottom by. So 5 goes into 5 once, 5 goes into 15 3 times. Be 1/3. Okay, now, anytime we reduce by a fraction that is equal to 1. 5 over 5 is equal to 1. Okay, so that's one way that we can create an equivalent fraction, is by reducing. Okay. The other way that we can create an equivalent fraction is by increasing the fraction. Okay. One way that we can increase it is by taking 5 over 15 and multiplying it by 2 over 2. Okay. 2 over 2 would be 10. That would be 30. Okay, so 10/30 and 1/3, all three of those fractions would be equivalent to each other. They all represent the fraction 1/3. Okay, each one of those is equivalent. See what? The directions will tell you which one you're going to have. Okay? If it says to simplify the fraction or simplest form, okay, those both mean to reduce it. Okay, means reduce. So most of the time they're going to tell you to reduce it. Now sometimes, I don't know if let me look here. Yeah, sometimes they're going to say, other instructions will be write two equivalent fractions to the given fraction. Okay, that's what we basically just did. Okay, let me show you another example of that.
Coach Smith.
say I have 3 over 27. Okay, so we're writing two equivalent fractions to this given fraction. Okay, the first thing we want to try to do is to reduce it. Okay, that's the first step. Now I'm going to show you one here in a second that you can't reduce. This one you can. Okay, and when we're reducing it, we're trying to find the greatest common factor between 3 and 27. Okay, 3 and 27. Trying to find the greatest common factor between 3 and 27. Well, the factors of 3 are what? 1 and 3. Okay, the factors of 27 are 1, 3, 9, and 27. So the greatest common factor would be 3. So I'm going to take 3 over 27 and divide it by 3 over 3. 3 goes into 3 once, 3 goes into 27 9 times. So that's one of your fractions, okay, is reducing it. The other fraction, we're going to take the original fraction, 3 over 27, and I'm going to multiply it by 2 over 2. We're always going to use 2 over 2. So tonight, when you're doing this, use 2 over 2. The reason being is because you could use anything, okay? You could use 10 over 10. You could use 1,000 over 1,000. You could use 22 over 22, okay? But then all of us are going to come up with a bunch of different answers. And then I'm going to have to answer, 12 questions tomorrow. Well, they've got this, they've got this, they've got this. So for our purposes, okay, understand that I could increase that fraction by multiplying any fraction that was equal to 1 by it. But we're going to use 2 over 2. Okay, that way we'll all have the same answers tomorrow on our papers. So when I multiply that by 2 over 2, that gives me 6 over 54. Okay, 6 over 54. So then my other fraction is 6 over 54. So those are the two answers to this specific problem. You don't list the original fraction in the answer. You only list the two new fractions that we came up with by reducing the fraction and then increasing the original fraction. Okay? I'm not increasing this by 3 over 3. Okay, I'm not using what I reduced it by to increase it by that. I'm using 2 over 2. Unless the fraction won't reduce. For example, this fraction here, 7 over, let's go 5/8. The fraction 5/8. Is there any common factors between 5 and 8 besides 1? No. Okay, so it can't be reduced. Okay, it can't be reduced. All right, now, it can't be reduced, so I've got to take 5/8 okay, 5/8, and I've got to multiply it by, the first thing we're going to multiply it by is 2 over 2, because that's what we've said. To increase the fraction, that's what we need to multiply it by, and that would be 10 over 16. That's the first one, okay? Then I'm going to take, since it won't reduce, I've got to have another fraction. So I'm going to take 5 over 8 and multiply it by 3 over 3. Okay? And that's going to give me 15 over 24. So my answer then is 10 over 16 and 15 over 24. Okay? And that's my answer. All right? And the reason we multiplied it twice, okay, is because it would not reduce. Okay? So the first time you multiply it, it's 2 over 2. And as we stated, each one of these fractions is equal to 1. Okay, Okay, each one of those fractions is equal to 1. Haley.
So anytime it can be, you multiply it by 3?
You multiply first of all by 2 over 2, and then take the original fraction and multiply it again by 3 over 3. Okay. Now, if they tell you, like these next fractions, 46 over 72, and they tell you write the fraction in simplest form. Write the fraction in simplest form. Okay, so that means reduce. That's what it means to write the fraction in simplest form. So I've got to find the greatest common factor between 46 and 72 and reduce the fraction by that GCF. Okay? So, what is the greatest common factor between 46 and 72? Okay, we know that 2 goes into it. Is there any other numbers that go into it?
9.
No, 9 doesn't go into 46. 7 doesn't, 6 doesn't, 9 doesn't, 5 doesn't. So let's try 2 and see if that ends up being the only one. So 46 over 72, and 2 is our GCF. So we divide by 2. 2 goes into 46 23 times. 2 goes into 72 36 times. So 23 over 36. Now, what we want to make sure is there any other common factors between 23 and 36? No, because 23 is prime, so 1 and 23 are the only things that will go into it. And 23 doesn't go into 36. So therefore, that's it. That's as low as it'll go. So how do we know if something's in simplest form? Okay. A fraction is in simplest form when the GCF between the numerator and denominator is 1. Okay, so a fraction is in simplest form when the GCF between the numerator and denominator is 1. Okay, it doesn't mean that the fraction is 1 over 1. It just means there's no other common factors than just 1. For example, we had 5/8 a while ago. Okay, the factors of 5 are 1 and 5. Factors of 8 are 1, 2, 4, and 8. Okay, the only factor they have in common is 1, so therefore you can't reduce it. Okay, you can't take it any further than what it is. All right, now, here comes the part that gets a little bit more difficult. That, of course, is the add-on to what we've done up to this point in math. Okay, 4m n to the third over 10 n to the second. And they want you to simplify that. Put it in simplest form. Okay? Well, what we've got to do is we've got to divide that fraction up into its parts. So, 4 over 10, m over 1, and n times n times n over n times n. Okay, in other words, I just did, the top is n times n times n, which represents n to the third. On bottom is n times n, which is n to the second. Okay, now, if you really want to look at 4 and 10, really what we're doing is this. Okay, that's what you really have. Okay, that's what we're doing when we simplify. A while ago, when we simplified 46 over 36, or excuse me, 72, that's what we're doing. We're writing the number in prime factorization. In other words, 4 written in prime factorization is 2 times 2. 10 written in prime factorization is 2 times 5. Okay, now I can just cancel out the things that are the same. Those are the same. Those are the same. Those are the same. So on top, that leaves me with a 2, an m, and an n. On bottom, I have a what? 5 and a 1, which is 5 times 1, which is 5. And that is that fraction reduced to simplest form. Okay, let me do another one of those. Let's see here. (42 r to the third over 56 r to the second). Okay. Well, if we divide that up, that's 42 over 56 times r to the third over r to the second, which 42 is 2 times 3 times 7. 56 be 2 times 2 times 2 times 7 times r times r times r over r times r. Okay. Now we just cancel things that are like on top and bottom, cancel them out. That cancels. That cancels. That r cancels. That r cancels. So on top then, that leaves me with 3r. On bottom, it leaves me with 2 times 2, which is 4. And that's your answer. Okay, so once again, this is the prime factorization of 42. Okay, this right here is the prime factorization of 56. Okay, any questions over that? The last thing I have two fractions. Okay, I want to put the two fractions in simplest form. Okay, so do that. Put 12/15 and 26/30 in simplest form. Reduce them, simplest form. So what is 12/15 in simplest form? Joshua? 4/5. Yep, 4/5. Okay. Now to get 4/5, you take 12/15 and divide it by what, Joshua? 3/3. That's where you get the 4/5. 26/30, we divide by what? 2. And you get what? 13/15. So are those two fractions the same? No. No, there's nothing about those that are the same. Are they exactly the same, in other words? No. So these are not equivalent. Okay? That's what they're going to do. They're going to give you two fractions. You reduce them down, and then the directions want you to tell them whether or not they're equivalent. Okay, let's look at another one. Very similar to this, 18/20 and 45/50. Okay, so if I reduce 18/20, what can I reduce 18/20 by? 2. 2 goes into that 9 times. 2 goes into that 10 times. So 9/10, let me move it up here where the fraction is. Now 45/50, what can I reduce it by? By 5. Divide by 5, 5 into that, 9 times, 5 into that, 10 times. So they are equivalent. Okay, you can also put no and yes. Okay? All right. Your homework. I'm going to go ahead and let you get started on it because we have about 20 minutes left in class. That way, if you have questions, you can ask away. Let me look at this to make sure it's the ones I want to give you. Yep. 41. All right. So we have 4.3, 12/36, and 41/46. Okay. Okay. Hang on. Let me pause this and I'll help you. Or stop it.